Welcome, everyone. We're going to get started. So, welcome to the Spark Meetup at TAG. Thanks, everyone, for coming out. So, my name is Rich, and I'm a software engineer here at TAG. And we have a heavy interest in Spark. And we're a social discovery site with products in the category of getting people together that don't already know each other. And what's exciting about TAG is that we have real big data problems. And I know that in the discussion of Spark and platforms like Spark, there's always the question of, well, what is big data? And it's nice to be in a room of people that are here because you have real problems and you have real problems of scale, and we can totally identify with that. So by show of hands, how many people here were at the Hadoop Summit about 1 year ago in May, June? Okay. Did you go by the show of hands to the Spark presentation? Okay. So if you didn't make it, it's probably because you didn't do what I did, which was camp out in the same room through a totally lame presentation so that you can have a seat and get in the door to the Spark presentation. But that's when Spark broke, and that's when Matai coined the phrase backup slide. And the first question came up, and his response was, "That was my first backup slide." And he hit click, and that's when I knew that we had somebody looking out for us. So I want to thank Amp Labs and the Spark team for developing this great product and this great ecosystem and getting this all together. We are actively hiring for software engineers to specifically work on streaming and to specifically work on machine learning and online streaming machine learning. So if you get the chance afterwards, please come talk to me. I'd love to say hi. And I'm going to turn the time over to Matai. Thank you so much.
Okay, thanks a lot, Rich, for that introduction, and thanks a lot to TAG for hosting this event. This is a really awesome space, and it's pretty tough to find spaces that can hold this many people and that are willing to host it. So we really appreciate you guys doing so. So I'm going to talk about the latest Spark release, which just came out last week, which is Spark 0.8, and I'll be joined by Patrick Wendell, who also did a lot of the work on this release. So let me start with just a little bit of background on things that have been happening over the past few years in Spark. So the past year actually has been a very exciting time for Spark when we've seen both a lot of new features go into the software and a lot of new contributors. So let me start with where we were actually less than a year ago. In October 2012, when we released Spark 0.6. At that point, Spark 0.6 was the biggest Spark release we'd put together. We had 17 people working on it. Most of them were from inside UC Berkeley, and it also represented a very significant refactoring of Spark itself, including a lot of features to make it easier to use. So I don't know how many people were actually, paying attention to it at the time, but some of the things we introduced in 0.6 were a Java API. This was the first language we supported beyond Scala. That's the first release when we started regularly publishing Spark to Maven and putting the infrastructure in place for that to make it easy to link to. And that's also the first release where we offered a standalone deploy mode and gave you a way to run Spark on a cluster without depending, for example, on Mesos. That just made it easier to install. And as I said, these were 17 contributors. So at the time, I thought, wow, that's a big release. We need to make these smaller in the future because it's just a lot of work coordinating these. It had taken about 6 months to actually coordinate this release and put all the refactorings together. So after that, in February of this year, we had the next release, which was actually quite a bit bigger, and this was the Spark 0.7 release. So in this one, if you don't remember, we added the Python API. That's again opened up Spark to a much wider range of programmers, and today I think it looks like about 25 or 30% of users are actually using Python. And we also introduced Spark Streaming, which lets you do real-time computation with this nice high-level API. And that's also the first release where we had more contributors to the project from outside the university than we did from inside. So we had 31 contributors and 20 were from outside UC Berkeley. And finally, last week, we put out Spark 0.8. And this is, despite our best efforts to make the releases smaller and smaller, this is actually our biggest release yet. It's about twice the number of contributors to Spark 0.7, and it's also a whole range of new features. And the part that's really cool about this one is if you look at the balance of sort of contributors to the project, really most of the contributors to the project now, most of the patches are coming from outside UC Berkeley. So it's really expanding as a community, and we have a whole bunch of other people participating. So that's a really exciting thing for us to see happen in this short a time span. Okay, so we're going to cover the actual features of the release in a little bit, but I'm just going to say a couple more words about this. So first, some interesting statistics. So in this release and in the past few months, most of the patches going into Spark are now from outside UC Berkeley. There are a lot of people at Berkeley still, working on it and working on research projects based on it. There are also a number of full-time engineers now, but now we're seeing a lot of work, including many, large patches from outside, from organizations like Yahoo and Intel and ClearStory Data, and a number of the other organizations using Spark. So that's very exciting for us. And then the second thing is if you look at the number of developers that we have and also the number of patches being sent in, and most of these metrics, we're actually an extremely active cluster computing project. So there's been a lot of work in the past few years to create alternative execution engines for clusters beyond Hadoop MapReduce. There's been different engines like Storm for streaming, or Giraffe for graph processing, or things like Impala and Tez for SQL. And out of these engines, Spark has by far the largest developer community now, and by far the largest activity in terms of patches being contributed and so on after Hadoop MapReduce. So it's really, it's a really exciting time for us, and we're very grateful to everyone who's been contributing to the engine to make this happen. So here are the people who contributed to Spark 0.8. Maybe it's kind of hard to see them, but I wanted to thank everyone. They're also in all the release notes, and some notes about this. So most of the organization with the most contributors is still UC Berkeley, but there are also 5 engineers here from Yahoo, and 4 engineers from Intel, and a number of engineers from other companies. In total, there are around 24 companies represented here. So that's what's going into this release. So there's a second thing I wanted to bring up that I think people have probably heard about, but it's very exciting for us, which is the announcement of Databricks. So we've recently launched a company behind the Spark open source project. Databricks includes me, it includes a lot of the Spark contributors from UC Berkeley, and we're very committed to growing the Spark stack and making it very easy to use, very powerful, and very successful. So just a few words about Databricks. So our high-level goal is to greatly expand Spark's capabilities. We want to make it easier to use, easier to deploy, and we also want to make it come with much more powerful libraries and utilities to do things with. And then the second thing is that we are deeply committed to open source. So as part of our model, part of our strategy is to be open source. We want to have the best environment essentially for doing large-scale data analysis. And the only way to imagine that happening a few years from now, the environment that wins is going to be open source. So we're doing this open source from the beginning. We have a great team. This is just some of the team. There are a few other people joining, but we have a lot of the key people from UC Berkeley joining this project. So Jan Stojka, who led the systems work in the AMP lab, is the CEO. I'm also joining the company. I've basically I'll be here for at least a year full-time doing this stuff. And then Reynold, who's behind Shark, Patrick, who's one of the main contributors to Spark, Andy, who's also a big contributor and organized all the training events so far, and Lee, who's one of the main people behind Tachyon. They're all part of the team. And I'm not going to say a lot more about Databricks. I'm happy to answer questions about it later. But one other thing is, even though it's still early on, we are hiring. So if you're interested in participating in something like this, we're looking for people both for engineering roles and for things like training and basically, teaching users how to build stuff with Spark. And I'll be glad to talk about that more later. Okay, so now to actually talk about the new things in the 0.8 release, I'm going to give that to Patrick Wendell. Patrick is a Spark committer, and he's also he's one of the most active developers of Spark so far. I think in the 0.8 release, Patrick actually has more commits than any other developer. And he's been working on it for a while. In the 0.8 release, he led the monitoring features and the new EC2 scripts, and he'll be glad to explain what's new in this release for you. Sorry, here you go. Here. Here's this.
Great. Okay, nice to see everyone. As Matej so nicely introduced, I'm Patrick Wendell. I'm a committer on Spark, and I'm also joined Matej at Databricks. So let's get started. What we're going to do today is just give a quick whirlwind tour of this fairly large release that we just put out. Here's the things that we were focused on going into 0.8. Number one goal was just to improve the overall usability of Spark. And you'll see that percolated down into a lot of lower level objectives. But we also wanted to improve the deployment scenario. So this related to things like improving Yarn, Mesos, and EC2 deployability. And we added this machine learning library, which is the first of what we hope will be a lot of kind of standard libraries in Spark for doing advanced computation on large data sets. Also of note is that this is the first release we've done through Apache. And as the end user, that probably doesn't make a huge difference, but in terms of our own release cycle, we had quite a learning curve learning how to do releases through Apache, and now we're on the other side of that. So future releases will be much more efficient for us. Finally, there's just a bunch of sort of new features in various parts of the code base, which I won't have time to cover because there's just too much. So the first thing we'll lead with is we've improved quite a lot the monitoring and metrics capabilities you get as someone running Spark or a system administrator who's responsible for a cluster where Spark is running. The biggest thing that we've done is just provide this UI inside of a Spark context that gives you exposes a lot of internal information about what's going on. So I'm going to dare to demo this. In theory, it should be open here. I think I just need to drag it. Oh, nice. Okay, exactly according to the instructions I was given by the fine folks at Tag. So I'm going to go through kind of what the various tabs in this UI are. I think I may need to zoom in a little bit. How do I do this on Apple? Nice. And I'm going to go full. Oh, wow.
Those arrows, yeah.
That's great. Yeah, I got it. Cool. Thanks a lot. So I'm just going to go quickly through the various features of this UI. The first thing we have, starting right to left, is just a summary of all of the executors we're running in this cluster. This gives you a really high-level snapshot of what's going on. And we can look at things like how much storage is on this executor, how many tasks have run, how many tasks have failed, which is nice if, for instance, one of the nodes is kind of flaky and has more tasks failing than other nodes. And one thing that's nice is we can sort all of these columns. It's kind of a fairly dynamic UI. With only 3 nodes, it's not so hard to find important events, but when you have 100 nodes, this thing is pretty useful. So the next thing we have is just a bunch of environment information. If anyone is familiar with kind of debugging various aspects of Spark, a common thing is that someone thinks they have a certain configuration in their Spark environment, and they actually, Spark is picking up a different configuration, either because they've entered the options in the wrong place, or one option is overriding another option. And this just quickly gives you a snapshot of everything that affects Spark's behavior and what it's currently set to. So this is really nice for debugging those kinds of issues. So third, we have this storage tab. There's only one RDD in this kind of dummy workload, but basically this shows you for each of the in-memory data sets you have, what kind of storage it's using, where it's distributed on which nodes, and gives you kind of nice statistics over this. And finally, we have this stages UI, which shows you kind of what's the progress of the current workload. What are jobs that have finished? What are jobs that are running? And for jobs that are running, it gives you some nice debugging information. So I'm actually going to go back to a job that did shuffle. And here, for instance, we get some nice summary statistics. This is only shuffling a tiny amount of data, so there's not much here. But it will give you things like what's kind of the 75th and 100th percentile of how much data was shuffled, what are those percentiles over how long the task took to run, and also we can actually drill down into the individual tasks and say things like, oh, okay, which task took the longest amount of time? This is super useful if you have stragglers, which are a really common problem in any parallel computation environment like this. You want to quickly say, okay, what are the tasks that took a long amount of time and where were they running or what were they doing? Okay, so that's in a nutshell this UI. But just as a user of Spark personally, I've already found that this really, really helps when you're trying to debug and understand the performance of your jobs. So anyone know the shortcut for showing a slideshow once you're in PowerPoint? Bottom left, oh, got it, okay, cool. All right, so that's the first thing, that's the one we demoed, but I'm gonna go through other things that we have as well. So another usability improvement we did is that we changed the way we link against Hadoop so that Spark no longer links against a specific version of HDFS client in our own dependency files that we publish. So it makes it much simpler for third parties that are depending on Spark, either applications that are on top of Spark, like Shark or some of the proprietary applications, or it's people writing standalone jobs that need to use Spark as a dependency. They can now just specify their own version of Hadoop that they'd like to depend on, and Spark is totally agnostic to which version of Hadoop they happen to be using. Another thing we really focused on was documentation. So this included a few very large new pieces of documentation that covered things like hardware configuration, monitoring, and also kind of how a Spark, for a given Spark, a run of a Spark cluster, which services are running on which nodes, and kind of explains various terminology we use like job and application in a very specific way. This is most helpful for like system administrators and other people who want to know what's running where in the cluster. We also wrote a programming guide for this MLlib thing, which I'll talk about in a minute. This is a standard library of machine learning functions. And we also really tried to bring all of the existing docs up to date with new ways, new things about Spark regarding how it's built and stuff like that. So one of the things that a ton of work went into was improving the deployability of Spark. So for people deploying Spark on Yarn, this has now graduated to something that's fully supported. We had kind of experimental support for it in a previous version of Spark, but now we actually have people running Spark regularly on Yarn clusters inside of Yahoo. A lot of this work came out of Yahoo, actually, and we kind of officially support it. We still don't support interactive shell on top of Yarn, but that's coming in a future release. This just supports standalone applications. We also upgraded the Mesos version, and we did a small fix that lets you deploy on Mesos without having to actually go and install Spark on every node. So if you have a Mesos environment where you're not a system administrator who can install things on each node, you can kind of bundle up Spark and submit it with your job. So that's something that people using Mesos wanted. And finally, I worked on this, so I'm familiar with it. We added a bunch of support. We had much better support for running on EC2. A lot of this was a big internal refactoring we did of this code base, but the things that are visible to users are that you can now launch these EC2 clusters in any region. So if you have data in US West or in Europe or anything, you can launch a Spark cluster there. And we can support some of the newer instance types that EC2 has developed in the last year or two. This is actually something that a lot of people use, and if you are not started using Spark yet, it's a great way to get started with very low cost and effort. You can just launch a cluster in 5 minutes on EC2. So getting to the end here, so one other thing we added, which was a pretty big investment, was this machine learning library. So this is a standard library that's going to be packaged with Spark. So over time, as we add optimizations and new features to Spark, the corresponding implementations of machine learning functions can develop directly with them. And it's a joint work with the ML-based project at Berkeley, which is trying to build higher level abstractions for machine learning on top of these low level implementations of various algorithms. You can read the list of things we support here. I recommend just checking out the programming guide. It gives it's like a maybe 3 or 4 page document that gives a bunch of information about how to use these and kind of how it works. And then there's kind of a long tail of other things. Here's a few ones that seem notable. One is that we've improved quite a lot of the support for scheduling inside of a single Spark application. So we support things like fair scheduling now. This is useful if you have a Spark application where long jobs and short jobs are running side by side, and you don't want, for instance, a big long job to block a lot of short jobs from making progress. The way to solve that is something called fair scheduling, and we've built a fair scheduler inside of Spark now to do that. Another thing is we added some support for doing rack-aware scheduling, which wasn't there before. There's a ton of new examples we had a PageRank example in Scala, Java, and Python. There's examples for all of the MLlib projects. And there's also some examples about how to interact with external systems like Cassandra and HBase. This is something a lot of people had asked about. It's not totally obvious how to do this, and now we just have really well-documented examples of how to do it. And finally, there was a lot of work that went into PySpark. So this is the Python API. It's been brought much closer to the full set of features we have in Java and Scala, so a ton of new stuff was added. And also, we support IPython, and we support running on Windows now. So I'll just give a quick note about compatibility. One thing that changed that's fairly significant in this release is that the package name changed from org.spark project to the full Apache name of org.apache.spark. So this will actually require users to change their code that depends on Spark when they upgrade to this release. Unfortunately, this is basically an unavoidable backwards incompatibility. We also took this time to rename, I think, one or two other classes. So if you depend on those, you may notice they've moved. But if you look, we very clearly document all of these cases in the release notes, so you'll know what to change. Also, we slightly changed the build process. So now you do this thing assembly instead of package in SBT, or also correspondingly in Maven if you're building with it. And if you forget to do this, you'll notice when you download the newest thing of release of Spark that when you start to run it, it will tell you, hey, you need to do SBT assembly. So this is what it's talking about. I'm just going to end with a quick note about feedback. So, we're investing a ton of effort in Spark right now, and what really helps drive that investment is getting good feedback from users and developers in the community. And it doesn't mean that you need to be some super expert on Spark to give us feedback. In fact, feedback from beginners is in many ways most useful for us. So things that we would like feedback on are kind of what could be better documented, which features are holding you back from either bringing Spark into production or maybe using it in the first place. And what do you find difficult? What's kind of the hardest thing when you're running Spark? The more we know about this, the more that we can help address those issues. So we have a survey that's up now, and it's been up for a little while. And actually, some of the feedback from the survey influenced what documentation we did for the 0.8 release. There was a few really good ideas about kind of high-level documentation that we were missing, and we acted on it. So yeah, so I'm just inviting anyone to go to the Spark website and click on the survey. It's just in the news piece. And encourage your friends to do it too, because we'd love to get as much feedback as possible. Okay, that's it for me. That's just a really high-level overview of the release. And feel free to ask me any questions afterwards. And definitely download and check this out when you have time. Thank you. So now, I think I'm handing off now to someone from Tagged. Here we go. From Bizo, sorry. And I'll let you introduce yourself. But yeah, thanks again, everyone.
Cool. My name's Josh. I work at Bizo, and I'm going to give a talk about how we're using Spark. This is kind of like a use case talk for us. So, really quick, what we do. This is just me some background because I want you to kind of understand what we're doing and how we're using Spark. So I want you to imagine my coworker here, Tony. He's actually in the audience tonight. Pretend he's a marketer, and let's pretend that he works for like a medical device company. Now, obviously, he's going to run some ad campaigns, right? But he doesn't want just anybody to see those ads, only medical professionals, because he's a medical device company, and especially people that are decision makers, he wants to see these ads, right? That's kind of what we do. We help people in business-to-business marketing get to the audiences they want to reach. Now, that's cool, but Tony really actually cares about what people do on his website. Specifically, he cares about page views, visits, buying stuff, conversions. That's like the thing that gets him most excited in life. So if you click this button, he'll do a little dance. He gets super happy. So the implicit assumption there is that if you show someone an ad, they're going to do more stuff that Tony likes. So we need to build tools for people that validate these assumptions. And specifically, we want to compare behavior of people that saw an ad versus didn't on your website. And that's kind of what we've built using Spark, the tools for this. So first example of a report here, this kind of shows you what your baseline visitors were. That's the gray line. The blue line is what we drove to your website. And this is kind of a very simple report that we built on Spark as a prototype that'll show you like the cost per visitor that it took to get those people there. The next thing's a little more exciting. This is the thing that actually compares the two groups of people that saw an ad versus didn't, and what they did. So, you know, green's good. This is from our personal website. We get about twice as many page views, about twice as many conversions for people that saw an ad versus didn't. So that's kind of what we've done. Now, the requirements for this is we need to process about 60 or 90 to 160 gigabytes every night. Yeah. Is that better? Okay. Cool. And we need to pull data from multiple sources to do this. So previously, we built all this stuff on Hive. And we haven't been super happy with it. And the reason why is it's really hard to unit test Hive. And there's a few other complaints that we've had. It's better than using raw Hadoop, but it's not like ideal. So we decided to give Spark a try. So higher level overview, we have a Spark cluster that runs on Amazon's EMR. This processes source data that lives in S3. And we output that back to S3 when the Spark job completes, load it into an OLAP database, and then our front end kind of loads that and queries the database to pull the data. So why build this on top of EMR? Why not use a persistent cluster? For us, one of the primary drivers is cost. We only need about 3 or 4 hours to run these jobs. So running persistent cluster 24 hours a day doesn't make sense for us. You also get some other benefits. You can kind of scale up and down the number of clusters in your EMR jobs based on what that specific job needs. So that gives us more flexibility there. So the way we have it set up is we can launch a Spark cluster with one click from Eclipse, or if you want to run it on a cron server, in our case we run every night, so we just launch the job from there. And we have a custom project to help us do this written in Scala. It's called Sparkplug. You can find this online at GitHub. It's open source. I'll talk a little bit more about that later. So how do we set this up? Well, what you do is we have 3 scripts. These are kind of based off the Amazon examples. And these are basically run as EMR bootstrap actions. So these scripts live in S3. When the EMR cluster starts up, it downloads the scripts and executes them. The install Spark script, it's pretty basic. It's going to go download the release version of Spark. We have our own repository in S3. So the script boots up, downloads that jar, unpacks it, configures the environment with all the cluster memory settings that we need. And then we periodically upload our Spark logs to S3 in addition to this script. The install job, we download and extract our versioned RGZ of the project code that we want to run. The way it gets into S3 in the first place is we use AMP build tool. So we'll tell AMP to compile our project. It'll upload it to S3. This script will go and download the project based on the job name. And then from there, we extract it into the Spark lib extra directory on the machine. So the class path will pick up when you run the Spark cluster. Yeah, so start Spark, that's obvious. I'm not going to talk much about it. It just determines whether or not the instance that you're running on is a master or slave, and then does the right thing based on that. So the report itself, remember that we're trying to compare these two groups of people who saw an ad didn't. And to do that, we have to stitch together multiple data sources, right? One source of data is our website activity logs, who came to our website, what they did, what page views they got. The other one is the impression logs from our ad server. So those logs tell you who saw an ad at what time. The last thing we need to do is we need to map the IDs between the two sources of data, right? We have our own internal IDs, and the ad server has its own ID for people. So we pull in a third source of data to do that mapping. So kind of what you want to end up with is an output data from our Spark job that looks like this, where our kind of key is our Bizo ID, a domain, and whether or not they saw an ad, because that's kind of what we want to do aggregation on. And the values that we're interested in are views, visits, and number of conversions. And in this case, we keep a map of conversion ID to count. And the reason why we do that is we're interested in what specific conversions someone did, not just how many conversions they did. So if we have that, then we can kind of easily compare these two groups in our OLAP database by aggregating across these dimensions, right? Okay, yeah, so what about some Spark code, right? So kind of the way we set this up and the way we think about structuring our Spark projects is you want to take each data source you have and you want to map that to an RED of case classes. So here's kind of a simplified example. Make that up here. So if we want to take, sorry, the microphone keeps cutting out, but if, yeah. Can you guys hear me back there? Is it a little quiet? Yeah, okay. I'll try to project a little more. So if we have, I'll just talk.
If you just want to tell them, we had the audio system reconfigured last week.
Okay.
We're still working out bugs, so this is as good as it gets. We're sorry.
Okay, yeah, it's okay. Yeah. So they were just saying that they just had their audio system reconfigured last week. Bugs are happening. This is as good as we can do. So sorry, I'll try to talk loud. Yeah, so what I was saying is for our jobs, we take each data source that we want and we map it to an RDD of case classes. This is kind of an example of the website logs. So what we do is you have a case class here. It's going to take in a string. The reason why it takes in a string is when you tell Spark to give you a new RDD, it's going to give you back an RDD of strings. And what we want to do is map that into that case class so you can kind of parse out the fields. In our particular case, our log lines are key value pairs, or not pairs, but they're a string of key values. So we end up parsing those out. So, for example, in our case class here, we have a field for Bizo ID and timestamp. We intentionally make these lazy. A lot of times we have 50, 60, 70 fields on these things. There's a lot of data that we collect. So we don't want to have to, eagerly kind of load all this because it's going to cause memory problems. So that's what we do personally. I think it works out pretty well because it gives you a nice API for constructing these RDDs. And then we just kind of pull them out of S3. So you kind of get a pretty consistent API when you do this. So as you add more stuff, it's very easy to kind of pull out the data sources that you want for multiple logs. Oh, yeah. Is that better now? A little bit? All right. Okay, so we make all these RDDs of case classes. That makes it really easy to pull out data from S3 for us. What about the rest of the job? How do we run this stuff? So kind of the way we think about structuring stuff is I like to structure things in terms of like 3 classes per your report. The first one is kind of your entry point. This is responsible for creating the RDDs, kind of what we were seeing in the last slide. And it's responsible for passing them to this next class, which is the report class. Now, this report class is kind of your brains. It's going to consume RDDs, and it's going to return an RDD. And I'll talk about why you want to do that. It's good not to mix these things together. And then the last thing you want to do is to use what we call a plug. This is used to configure and launch your job. This is a class directly out of that Spark plug project I was talking before. So an example job kind of looks like this. You just have a basic main method, start and end date, and then we're going to pull out our RDDs from S3. We're going to construct our report, tell it to run it, pass in those RDDs, and then save our results back out to S3 when we're all done. The example report, this is the thing that takes in the RDDs. And this is the thing that's going to return an RDD, right? So we take in our RDDs. We're going to map from this RDD into a tuple2. This is kind of a pattern you see in Spark all the time. The reason why is because you get an implicit conversion from a normal RDD to a pair RDD. That means you get lots of extra fun methods for like joining and co-grouping, that kind of thing. So in Scala, you see this all the time. So we do that, and the reason why we're doing that is so we can join our weblog data with our ID mappings. We're going to do some more massaging and stitching of the data, and eventually you kind of end up returning this resulting RDD here. And lastly, here's an example plug. We have this abstract plug that's out of that Spark plug project. You specify your job name, what arguments you want to run with. Typically, these are the date ranges that we have, the package name, and the project name. These two are actually important because when our install Spark job script runs, it's going to look for these names. So we're passing these as bootstrap actions, right? And in the arguments, we're passing our job name. That's how it knows which jar to pull down from S3 and run for your specific project. So why do all this? Why do these 3 classes things? The answer for us is it makes it really easy to test. And the reason why, here's an example test, and I'll kind of walk through what we're doing, is if you only do transformations on RDDs, then it makes it really easy to unit test that. If you add in other stuff like parsing arguments or like trying to mess with Amazon while you're doing that, it's very difficult to test. So what we do is you typically import like a local Spark context in Scala. Then we have this run method down here. And what this does is you can basically turn a sequence of your case class lines into an RDD using the Spark context parallelize method. And so that's kind of how we construct our unit tests, is by saying, okay, well, I want some website log lines, and we have a apply method on that companion object, so we can pass in data. So basically, we can construct, kind of like fake data fairly easily. Put a sequence of that, call run, parallelize will give us the RDD, and then we can assert against that by saying, I want the first thing in the RDD, and it should be equal to this case class. So that's another reason why it's kind of nice to have these case classes, is in Scala, they will do equality, serialization, and a bunch of other stuff automatically. So it's kind of nice to do that. All right, so yeah, in short, just to sum up there, if you only do transformations and RDDs, it's easy to test. Try to make it easier on yourself to create test objects, and then use the Spark context parallelize to do that. Here's an example of kind of how we did that. If you're not familiar with Scala, you can have what's called a companion object. An apply method just makes it kind of a shorthand syntax for constructing one of these, and then you can pass in some fake data. Now, remember, because our RDDs are going to be like an RDD string to begin with, our case class is always taking a string, so we have kind of a helper method to translate these extra data fields back into a string, so our constructor will do that properly. So we've been doing this for about 3 or 4 months now, running these jobs. We're now running multiple projects, various other things that used to be Hive reports that are now Spark reports. And to kind of help us out with that, we now have a library called Spark Common. And this contains a lot of our abstract jobs, report and flood classes, but it also contains case classes for all of our common log stuff, which makes it really easy for someone coming in that's never used Spark before to kind of include Spark Common and get a bunch of stuff for free without needing to do a lot of manual kind of setup. We also have common utilities and that kind of thing. One thing that's really common for us is mapping a sequence of page views into a sequence of visits. So it's nice to have those kind of utility methods. So our experience using Spark has been really good so far. Things that we like better: unit testing is a huge win for us. It was really a huge pain in the ass to work with Hive and like do any kind of unit testing. The abstraction's a lot easier. It's really nice to be able to make like an abstract class for your jobs. And the end-to-end Scala code is really nice. Your code is no longer fragmented across a bunch of different projects. You don't have to go looking for UDS or UDAF somewhere else. Caveats. So some queries are a little more verbose than their Hive counterparts. I'll talk a little bit more about that later. Watch out for shutdown signals. So this is one of the things we ran into, is if your EC2 instance receives a shutdown signal, Spark will try to resubmit the task to it, and after 4 times it'll fail, and then your job will kind of blow up. That sounds bad, but in practice it actually happens fairly rarely. It's usually like if you get an EC2 termination report or something like that, or if you're attempting to use spot instances, that can happen. And serialization can bite sometimes. You have to be a little careful in your job classes if you hold on to references of objects when you shouldn't be, or you're creating objects when you shouldn't be, because Spark's going to serialize your class around and ship it to different nodes. So sometimes you can be bitten by that if you're not careful. Talk a little bit about debugging, how we handle it. So we have 3 sources of logs. Since we're running on EMR, we have our Bootstrap logs. Those are kind of debugging our startup. Make sure Spark's configured correctly. Our job steps, which are kind of the master node and where you see output from the scheduler. And then finally, we have our actual individual Spark worker node logs that you can look at. And that's if you, those are actually used fairly rarely for us. It's mostly if you run into one of these serialization errors or your node shut down and you weren't sure why. And, but yeah, most of the time it's you're looking at these job step logs that you'd want to look at. One thing that's really nice, 90% of the time you get a really nice stack trace with the exact line where the failure occurred. If you don't, then there's a lot of different logs that you'd have to comb through, and that's kind of a pain. So I recommend trying to automate that. We've done that. We have a WTF Spark script. You pass it the job ID, and then it asks you, hey, which type of log do you want to look at? And it'll attempt to go find the one with the exception that you want to see. That makes it a lot easier. The other thing I'll mention is RDD to bug stream. That's a really nifty method that'll actually show you the dependency graph of your RDD, so you can kind of see what computation flow you're going to take. That's useful not only for debugging, but if you're kind of interested in seeing when you're going to do a shuffle, if you're worried about performance, then it's really nice to do that. So other thing I'll mention is just talking to you kind of around before the talks. There's a lot of people that are kind of like getting started with Spark, want to get it more involved in your company. If you're interested in doing that, really recommend doing a Spark Hack Day. That's one of the things that really helped Spark take off at our company. And it's a great way to get people excited about using Spark. Or if you're new to Spark, it's a great way to kind of play around with the technology. So what we did is we have all these Hive reports, right? So we said, okay, well, everyone pick a Hive report and then translate that to Spark. Try to get it done in a day, try to unit test it, and try to run it. That actually worked out really well. We did put some preparation work into that. We gave a prelude talk to people that are a little more junior or don't know much about MapReduce or Hive and a Spark primer. And then the other thing that's really helpful is build them a simple example project. Give them something that they can run right away, preferably with some unit tests so they can see how they construct those. Basic translation, if you want to play around with translating a Hive job to Spark, your select statement's typically going to be a map, sometimes reduced, but almost 90% of the time it's a map. You're always pulling from RDDs for your data set. That's how you translate them. Join is going to be a cogroup. That's kind of like the primitive operation in Spark. You can also call join or left outer join, but those are usually built on top of cogroup. You can call where's obviously filter, and then group by is going to be either group by key or reduce by key, depending on what you want to do. This is not covering all the edge cases, but this is the basic translation of how you would cover this. Sometimes it's not super nice though. One of the kind of annoying things that we ran into on the Spark Hack Day that people were complaining about was kind of doing a count distinct kind of example, right? So in this case here, we have an RDD of user data, and it has an ID and then some data on that. And we're kind of interested in counting up the number of uniques that have the same data. So the first thing we do here is we kind of translate it so we have a counter. And then we're going to reduce by key, so we only count the distinct unique people one time. Then after that, we now can drop the ID, because we're interested in the people with the same data, not necessarily their ID, and then we end up reducing to get that. So that's kind of a lengthier example of what it would take to do that, versus in Hive, you can just say, I want to count by distinct, and it'll kind of do the right thing. So to make that easier, one of my coworkers spent a little bit of his hack day with a new API where you can just say, okay, I have an RDD, I want an aggregation on it, I want to group by this field, and then I want to count distinct on this field, which is pretty nice. And the way this kind of works is this kind of triggers an implicit wrapper around the RDD. And then these are extra methods on that wrapper. So you can kind of, the point here is you can kind of build your own DSL. There's lots of opportunities for abstracting for stuff that you do all the time. That's one of the nice things about working in a language like Scala compared to Hive, where it's very difficult to extend the SQL language to add new keywords or stuff like that. So wrapping up, we've had very good experience using Spark. Very few failures actually over 7 months. The failures that we did have were usually our fault because of serialization errors or stuff like that. There's a few minor bumps, but it's a very new technology. I think those are far outweighed by the testing advantage that we get. And being able to use Scala is awesome. The other thing is that the ideal memory settings for our job is a little bit fuzzy about how we should configure those. Yeah, sure. Yeah, and that's it. Thanks. Happy to answer questions if you have any.